Good morning, everyone. Hope everybody is fine. Tony Massad with you today. We will be discussing the derivatives of the carboxylic acids, part 2. Reactions involving acid anhydrides. The acid anhydrides, when involved in chemical reactions, they simply split into two pieces. Let's start with the first reaction between acid anhydride and hydrochloric acid, or HCl. During this reaction, the acid anhydride breaks into two pieces. One piece takes the H from the HCl and produces the carboxylic acid, and the Cl takes the other piece and joins with it to form the acyl chloride. Another example to discuss: acid anhydride reacting with alcohol. Again, the acid anhydride splits into two pieces. One of the pieces joins the R prime to form an ester, and the OH joins the other piece to form the carboxylic acid. Specific examples, please. We've got the acid anhydride, ethanoic anhydride, reacting with hydrochloric acid. During this reaction, remember that the ethanoic anhydride has got two pieces. Each piece contains two carbons. So the H joins one of them to form the ethanoic acid, and the Cl joins the other two to form ethanoyl chloride. Let's elaborate on the last reaction. Again, we have ethanoic anhydride reacting with ethanol. Now, during this reaction, the acid anhydride breaks into two pieces. Now, each piece, of course, has two carbons. So, the two carbons of each piece reacts with CH3CH2 to produce the ester, and the OH joins the other piece to form the ethanoic anhydride. Now, a note to be passed on, please. When you simply have a derivative, which is the acid anhydride from carboxylic acids, the rule is, if the acid anhydride is derived from a specific carboxylic acid, the number of carbons in the acid anhydride is always double the number of carbons in the carboxylic acid. For example, propanoic acid has 3 carbons. Propanoic anhydride has 6 carbons. Butanoic acid has 4 carbons. Butanoic anhydride has 8 carbons, as shown on this slide. Now, please, to recap, again, every time you have an acid anhydride involved in a chemical reaction, the two pieces split, and the two pieces join other elements or group of elements to form a new compounds. Esters are also considered derivatives of the carboxylic acids. The general formula of an ester is CnH2nO2. The ester always has 2 oxygens in its structure. Dealing with the structural formula of the ester, it's RC double with an O, then single with an O, R prime, where the COO, which means C double with an O, single with an O, is the ester functional group. To note here, only the R can be replaced with H, but R prime can never be replaced by H for a very simple reason. If the R prime were to be replaced by an H atom, then it is no longer an ester, it just becomes a carboxylic acid. So always, the alkyl group that is behind the COO can be replaced with an H. On the other hand, the alkyl group R prime, which is connected to the single oxygen, can never be replaced with an H atom, because it will no longer be an ester, it will just become a carboxylic acid. The name of the esters. The general naming of the ester is alkyl alkanoate, where the alkyl name is derived from the alcohol, and the alkanoate name is derived from the carboxylic acid or one of its derivatives, which are the acyl chlorides or the acid anhydrides. Preparation of the ester, it's already discussed during the year many times. Now we have to really shed some light on the naming of the esters, ladies and gentlemen, so I need great attention as I go through the explanation of this part. Examples. We've got CH3C double with an O, then OCH2CH3. The name of this ester is ethyl ethanoate. Here's the explanation. Looking at the right side of the ester, we've got CH2CH3 bonded to this oxygen. This is the part that comes from the alcohol. Since it has 2 carbons in it, you start the name with ethyl. Then you move on to the next part of the name, which is the part called the alkanoate, which is derived from the carboxylic acid or its derivatives. Looking at the C double with an O, we clearly can see that it has 2 carbons, C double O, and behind it we've got CH3. So this is derived from the ethanoic acid, therefore we write down ethanoate. So the name of this ester is ethyl ethanoate. Let's complicate things just a bit. Let's look at this humongous ester we have down below the ethyl ethanoate. Let's focus on the C double with the O, single with the O. On the right side, where the oxygen is, the lone oxygen, it is connected to CH, then the CH is connected to CH2, then CH3, and this CH is bonded to CH3. Now, the mechanism or the way we have to go around naming this ester. You have to locate the longest continuous chain of carbons connected to this oxygen. Looking at this oxygen, we've got 2 chains. Chain that is made up of 2 carbons and chain that is made up of 3 carbons. So the one to choose is the one that has 3 carbons. This will just make the CH3 that is connected to the CH a branch. So we start the name with 1-methylpropyl. Why do we write down 1-methylpropyl? 1-methyl to indicate that the methyl is bonded to the first carbon of the main chain that is connected to the oxygen. So 1-methylpropyl. Now, the next part of the name, you have to look at the C double with an O. Again, you start counting from the C. You go 1, that's the first 1 carbon, then it has CH right next to it, CH2, CH3, and it has also CH bonded to CH3. But the longest continuous chain is the one that has 4 carbons, which makes the CH3 that is connected to the CH a branch. So we call it 2-methylbutanoate. So as you can see, the name of this ester is 1-methylpropyl 2-methylbutanoate. It is like a newspaper, ladies and gentlemen. Let me recap it again. The focus, you have to simply focus at the C double with the oxygen and single with an oxygen. The part that is connected to the oxygen has got to have YL endings to the name. So looking at the right side of this ester, we have CH, CH3, and we have CH, CH2, CH3. Now, the CH, CH2, CH3 is longer than CH, CH3, so the CH, CH2, CH3 is the main chain, which is propyl. The methyl becomes a branch on this chain, and it is located on the first carbon, so we call it 1-methylpropyl. Looking at the left side of the ester, where we have the C double with the oxygen. This C double with the oxygen is bonded to CH, CH3, and also is bonded to CH, CH2, CH3. But C bonded to CH and CH2 and CH3 has 4 carbons, while the C bonded to the CH and CH3 has 3 carbons. So the main chain right here contains 4 carbons, and the methyl just becomes right now a branch on this main chain, and it is located on the second carbon. Therefore, the other part of the name is 2-methylbutanoate. When using condensed structural formulas, the reaction between the benzoic acid and methanol. I'm just using an example right here, please. So using condensed structural formulas, we have to write down the reaction between benzoic acid and methanol. Benzoic acid is C6H5COOH, and the methanol is CH3OH. Of course, it's a reaction in equilibrium, producing the methyl benzoate plus the H2O. Now, during this process, of course, the benzoic acid loses the OH, and the methanol loses the H to form H2O. Then you join these two molecules together in the formation of the ester. Now the name of this ester is methyl benzoate. Again, looking at the oxygen that is a lone oxygen connected to the CH3, we call it methyl, and the C double with the O, it is simply the part which is derived from the benzoic acid, therefore the name is methyl benzoate. Okay, let's shed some light on esterification reactions now on this last slide. Carboxylic acid with an alcohol produces ester plus water, and the reaction is reversible. The reaction is, we can just use incomplete, it's limited, it's slow, and it's athermic. Now look at what happens when you use the derivatives in the esterification reaction. When you use the acyl chloride with the alcohol, you produce the ester plus HCl. When you use the acid anhydride with the alcohol, you produce the ester and carboxylic acid. Using the derivatives, the characteristics change dramatically. Instead of being slow, incomplete, and athermic, now with the use of the derivatives in the esterification reaction, the characteristics are fast, complete, and exothermic. Now, I'm going to present to you here the preparation of benzoyl chloride as a recap of the entire derivative lesson and its esterification reaction with methanol. Let's start with the preparation of the acyl chloride. Now recall, ladies and gentlemen, that the acyl chlorides can be prepared by either using thionyl chloride SOCl2 or phosphorus pentachloride PCl5. In both cases, we simply yield the derivative acyl chloride from the carboxylic acid. So in this case, I'm using the SOCl2 with the benzoic acid to produce the benzoyl chloride plus SO2 plus HCl. Now the benzoyl chloride right now is involved in the esterification reaction with methanol to produce methyl benzoate as the ester plus HCl. The other example is the preparation of benzoic anhydride and its esterification reaction with methanol. You start with two molecules of the benzoic acid. Of course, the reaction is reversible, and we use the P2O5, which is a very, very strong dehydrating agent, which simply absorbs the water from the 2-carboxylic acid, leading to the production of the anhydride, in this case the benzoic anhydride. Now using the benzoic anhydride now in the esterification reaction, you produce, of course, the ester again, which is methyl benzoate, and the other part or the other compound is benzoic acid. Now the hydrolysis of the ester is just the opposite of the esterification. It's when you put the ester plus the water in reverse reaction, of course, to produce the carboxylic acid and the alcohol. This is discussed earlier when we dealt with the esters and the equilibrium lesson earlier this year. So the homework, ladies and gentlemen, please to be done, and it's a humongous homework. It's on pages 196 to 204. I'm sorry. The numbers are 4, 10, 11, 12, 13, and 14, and pages 216 to 219, numbers 5, 6, 7, 8, number 9 without part 3. And of course, I will be passing along to all of you guys the answer key for every single exercise of this humongous homework. Thank you so much, and God bless.